Hello everyone. We are more than excited to be here. We are RHS Robotics, and we're just going to start off with introducing ourselves. So my name is Taylor. I am a senior on the team. I've been doing this for 2 years now, and some of the stuff I do is organize outreach, hardware, and a little bit of software, not too much though.
Hi, I'm Josh McMillan. I'm on the team as well, and my main job is software and overseeing things in that department.
I'm Colton. This is my first year on the team, and I just worked on hardware.
Hello, I'm Troy Bechtel. I'm a senior. This is my second year, and I do a lot of CAD modeling on the computer and work with hardware.
Hello, I'm Derek Stratton. This is my 4th year on the team. I'm a senior, and I mostly do hardware and some driving.
I'm Jonathan. This is my 3rd year on the team, and I mainly do hardware, and also I help with driving.
I'm Sarah. This is my first year on the team, and I mostly do hardware, and that's pretty much it.
Okay, so I guess we'll start with saying that we are more than excited that you guys are interested in starting a team. First is a great overall experience in many ways. It familiarizes you in science, math, and technology. But overall, it's just a fun experience getting to compete and work with your teammates and just being committed to a team and building robots. There are also scholarships or college scholarships for FIRST members. There are 3 different levels in FIRST, there's 4, starting with junior FLL, and that's kind of just with working with Legos. And then there's FLL, which is First Lego League, and that's where they start building a little robot with Legos, and they have the NXT, which programs the robot. And then we are an FTC team, which is First Tech Challenge, and that's when you start building robots with metal or a Tetrix kit. And then there's FRC, and that's First Robotics Competition. And that's where you build robots like this, but way bigger. They're probably about like 5 by 5, and they're really big robots, and you compete, and then if you make it to Worlds, it's a lot of fun. But so first you guys have to know how to get started and how to start a team. The first step in starting a team is building it. So I'm just going to read this from the website online, usfirst.org. Teams are made up of students grades 7 to 12 who are ready to take on the challenges applying science, technology, engineering, and mathematic concepts to robotics. So first you guys have to gather team members, gather coaches, figure out who's going to be on the team, see who's interested, and just make sure you know who's going to be on the team and who's going to be mentoring and coaching you guys. And once you guys have a team, then you can go online to usfirst.org and you can register the team. There's just a tab that says register the team, and then you will fill out release forms for each student who wants to be on the team. And once the team is all registered, and by the way, I'll be giving these instructions to whoever's in charge of all this so that he knows for sure how to do it. There are a few things you're going to need once you get started. You're going to need the FTC Samantha Wi-Fi module. You're going to need the NXT Mindstorm from Lego. And you're going to need a Tetrix kit. And you're going to need the program language. And all of that is an expense except for the program language you can just download on the computer itself. And then there's additional cost for shirts if you guys want a costume, the field to practice on at school, and traveling. So Josh is going to tell you guys why you need the Samantha module, why you need the NXT, and why you need the program language.
Okay, let me just bring the robot over here. Okay, so this is our robot. Now, if you're going to spend all this time building a robot, you want to make sure it's more than a piece of contemporary art. You need to make sure that you have this NXT, which is a brain that controls all the motors and servos that are on the robot. You can get this from Lego, and you just need to install a special firmware so that you can program using the different languages that are used for this competition. Also, I don't think we have it on this robot. You have the Samantha module right here. As you can see, placed on the tower of this robot here, this little black box. What this allows you to do is connect with Wi-Fi and all of that, so that when you're on the field, they'll connect to it, and so you can control it remotely with a controller. Now, to program these robots, there's two main languages that you can use. There's Robot C, which is a special compiler for the C language, and then there is LabVIEW. So there's two differences. LabVIEW is more visually oriented, so you'll be programming by dragging blocks, and then you'll specify what that block is for, if that block is to make a motor move, or whatever you're using, and then so you use that and you string these blocks together, and based on where the program goes with each block, the robot or the NXT is going to read that and then tell the robot what to do based on what each block commands the robot to do. This is very useful just for a nice visual language for people starting out, and it is also used by many scientific fields that do data testing. They'll use that and they'll conduct their tests and grab whatever they get from their experiments, and they'll string it all together with that programming language. The other programming language, C, is pretty bare bones. It's when you write out manually everything that the robot is going to do. And with this, you have a greater deal of control, and the programs take up less space, so you can fit more onto the brain. And also, if you're going into engineering or anything that's going to be programming a drone, or if you want to even make a game or anything like that, they all use C, and that's a great jumping point to learn all those programming languages out there, and that's a very valuable skill if you want to get a job, because anything involving technology is going to need you to program, and so that just gives you such a great head start with all of that to program. Based that they'll put lines on the field so you can follow the lines and go to the correct place you need to go, or just tell the difference between a field element, if it's red or blue or anything like that. And then there's also a gyroscopic sensor, which it detects turning. There's an accelerometer, so you can measure acceleration and all of that, and if you're flipped over or anything of that sort. And there's many other sensors. I can go on forever. There's sensors detect weather. There's tons of them out there. So it's a lot of fun to play around with when you're programming the robot. So now we'll talk to you about sort of how we come up with the ideas to put onto the robot.
So every year, FTC releases a video to YouTube about the game and what the board will look like. So after that, after we watch the video, we go and start brainstorming. We write up all our ideas on a dry erase board, and then we test them. So.
After we use collective thought with the whole team and we put it on the whiteboard, we take it and we put it in simple ideas. We build in prototypes. When we do prototypes, we don't really typically use metal, so we don't take hours at a time, wasting our time. We use cardboard, duct tape, zip ties, simple stuff. And you come up with a simple idea and see if it would work. If it looks like it would work, that's when you try to bring it to life. With metal, you take your time to build it.
So after you've done your prototype stage, you will narrow yourself down to 1 or 2 ideas, and with those ideas, you'll make them out of all your ABS plastic or metal, all that kind of stuff, and that'll be your main parts in your bot. That'll do most of the scoring or stuff like that. So usually you will not want yourself to keep changing ideas all throughout the year. You usually want to stick to 1 or 2 main ideas and keep that idea, because it's better to get really good with one idea than to keep changing your ideas and trying to find the best idea.
Why don't you tell them a little bit about the robots and what mechanisms do?
Okay, so for our main scoring idea, we came up with a bucket like this. It uses zip ties attached to a motor to suck in about 2 by 2 inch yellow cubes. It'll bring them into here. You'll go over a basket that's on like a teeter-totter bridge, and you'll release the servo, dropping them into the bucket. And that's what goes on for the first 2 minute and a half of the game. In the last 30 seconds, you will use a flag. There's a flag lifted by a pulley, and you will use this to spin the flag. And then also, you can use a lift design, which we came up with this kind of design. Pull your robot up and score extra points.
One other thing I forgot to mention, before you guys start building a bot, a good thing to do is use Creo, which is a 3D modeling on the computer. And you can model out your whole bot and see what you want to do, what direction you want to go with your bot. And it's just a good visual aid to see what you want to do. Judges also like it very much when you guys do 3D modeling. So when you guys like doing that, it's very simple to learn. They have tutorials on YouTube. That's about it.
So I'm going to talk about what the competition days are like. Usually the competition is held at a high school somewhere very far away from here. And so the day starts by getting up really, really early and having to drive usually a long distance and show up around 7 in the morning at the competition itself. You start with hardware inspection and software inspection, which what they do is they make sure your robot is legal, like it doesn't have any uranium or explosives on it. And also they make sure that it'll still fit within an 18 by 18 inch cube because we're not allowed to be any bigger than that. And at a software, they make sure your robot connects to the field and doesn't go on an evil rampage when it's not supposed to. And then after that, you're called to judging. And what judging is your whole team and your robot goes to a classroom a ways from the field. And there's 3 judges, usually local engineers, who work for things like NASA and Lockheed. And you will tell them about your robot, about your team, how you do everything, pretty much what we're doing here. And from that, they will take your engineering notebook, which is pretty much a journal of what you've done all year with the hardware and software on your robot. And from that, they will plan out awards, such as Inspire Awards and Judges' Choice Awards. And to advance to the next competition, you don't necessarily have to win at your competition. If the judges nominate you for certain awards, you can go on to the next competition. After judging, you spend until about noon in qualifier matches. And the qualifier matches are just normal matches, and they're not elimination. You continually go around playing other teams. But the difference between FTC and other sports is that you have an alliance partner, and so instead of having 2 robots on the field, you have 4. And 2 of them are paired up against 2 other teams, but it's not a permanent match, because in the next match, you could be paired up with the guy you were against. And so it generates a lot of friendships between the teams, and you also get to go around sharing ideas between the robots. In fact, stuff like this little bucket on the side of our robot here, we took that from other teams' designs that we saw and liked. And so that's one cool thing that we can do at competitions is look at the other robots and see, hey, that's a pretty cool system, we'll use that. After qualifiers, you get ranked in about 24 teams, 1 to 24. The top 4 teams get to pick their allies for the semifinals. These are permanent alliances, so they don't keep getting switched. And so if this robot picked this one in alliance, they would be together for all of finals. And there are 4 alliance teams, and teams 1 and 3 play each other, and then teams 3 and 4 play each other. And they go around, and this is elimination, and it's best 2 out of 3. And then the top 2 teams out of that go into finals, and that's also best 2 out of 3. And that's how you win at a competition.
So there's more to robotics than just building your robot and competing with it. Another thing that we do as a team is give presentations. So last year and this past season, we've given a couple presentations, such as we went to the Poppy Festival and had a booth there and talked to people about our robot and robotics. And then another thing we did was last summer we went to the YMCA and gave a robotics presentation there and had a couple of activities for the kids to do there. We also sometimes give presentations at schools like now, and last year when we went to a tournament in Las Vegas, we also stopped by a school and gave a presentation about robotics. We have a couple of outreaches that we're preparing to do also. We're planning to give a presentation at a nursing home next week, and we also gave a presentation at a Boy Scout troop. So the judges like to see you in the community and giving presentations to different people and telling different people about robotics.
Yeah, so like Sarah said, community outreach is a huge part of robotics. It's not just about building the robot and programming it, although that is huge because you want to win the competition. The judges, like Sarah said, like to see that you're reaching out to your community. Our biggest event in community outreach is called the VEX Workshop. And if you guys join our creative team, we would love for you guys to join us in this workshop because we collaborate with all the FTC and FRC teams of the AV, and we make this workshop. And in this workshop, it's a week long. There's various presentations that come in from engineers from NASA and Lockheed. But throughout this presentation, the kids get to build a VEX robot, which is something like this, but smaller and with bendable metal. And then at the end of the week, the kids come together, all the teams, and they have a match and they have competition just like we do. And then there's a winner and they get a trophy and all that. I guess we should probably talk about a little bit what goes on in the match because we didn't really specify that to you guys. Every year there is a new game, and in this game you have to be able to do certain things. This year we had to pick up, like I said, little yellow blocks with some sort of mechanism. See, for theirs they just scoop it up and dump it out. For us, we kind of use a vacuum mechanism and then we dump it. Another thing you had to do was raise the flag and then also raise your robot. And you are given 2 minutes and 30 seconds to do either of these things. If you can't do them all, it's okay. A lot of robots can. We're still working through our errors too. The first 30 seconds is autonomous, meaning that whoever is programming on your team has to have a program to make the robot move on its own and score a block without touching it whatsoever. And then after that period's done, the 2 minutes come in, and that's where you try to score as many blocks as possible. And the last 30 seconds of that 2 minutes is called the end game. And at the end game, you can either raise the flag or raise your robot. As you can see, robotics has multiple things you can do. If you're not good with one thing, you're good with another. If you're not good with that, then you're good with something else. See, for me, I suck at programming robots, but Josh here is great at doing it, and it's kind of, makes me insecure. But anyways, I mean, these boys are good with hardware. Sarah's really good with community outreach too. I can't drive at all, but I mean, my brother, he also does 3D modeling on the computer. If you're good with designing things, you're good with art, that's something good you can do. So see, robotics is not just about building the robot. There's so many things you could do, and everyone is involved. So yeah, with that, are there any questions? Yeah?
How much is like the cost of it?
Okay, I'm glad you brought that up. So, like I said, you were going to need a Samantha Wi-Fi module, the Lego Mindstorm NXT, and a Tetrix kit to build a robot. And the prices for those Well, just to register your team is $275 in the US. The Samantha Wi-Fi module is $85. The Lego Mindstorm NXT is $265. And the Tetrix kit is $665. Now, I know that sounds like a lot of money, and if your school cannot cover the whole cost of it, we do have sponsorships through our team. We sponsor a couple of FLL teams. So, I mean, and there's also grants you can look at. I don't know if any of you have been on an FLL team, but there are grants given to FLL members who are graduating to FTC. So if you go to the website, there's multiple things you could look at for extra money if the school cannot cover the whole costs.
Also, there's tons of companies that they have funds just waiting to be poured out on students doing something like this. Like when this team was started, the founding team members actually wrote to NASA, and so they got sponsorships from NASA, and we have sponsorships from Lockheed Martin and Northrop Grumman, and you name it, because these places, they have these funds, and they're just waiting for high schoolers to do something that's, they're waiting for someone to support with this money, because not a lot of people do this, and when they see a bunch of high schoolers interested in engineering and they see this as future employees or future innovators, they are more than happy to help you start that team. So you'd be surprised if you just contact these companies, they'll be willing to support you in starting a team.
Were there any other questions? Yeah?
How long does it usually take to build one?
All year. It's never done big builds.
You can
It's
always
always
do
being
more.
improved.
Well, how long did it
We
take you
usually-
guys to get it actually running for the
We
first
usually have
time?
it 2 months before the first competition, and we normally have a running bot and do most of the obstacles. But through the whole entire year, you just keep seeing newer ideas and better ideas, and just keep upgrading your bot the whole entire year.
They released the game at the beginning of the school year, and so we start building at the beginning of the school year, and our first competition is usually in November. So that's about how long we have to finish the first rendition of the robot. Then we can change it from there.
Yeah, you could have a square that drives in about a week, but you just keep on adding up to that, and it's not your thing, and it just keeps getting better.
Or worse? If anyone has any more questions, we'll answer them, but if not, we can go ahead and start driving around the robot. Also, if anyone would like to try driving it themselves, they can. So with that, were there any last questions?
Do they have names?
Yes, they do have names. We've called this one Jack. I don't know if any of you guys have watched Duck Dynasty, but we're obsessed with that show. So, and we actually wear Duck Dynasty beards at our competition. So this is Jack, and this is.
Yeah. We're calling it Pythagoras right now because it's a triangle. And it's a very original name. He calls it She Said. Don't really know why.